Hello, everyone, and thank you so much for joining us for this webinar today with Shiny Basu from Dell. My name is Rashida Clements, and I'm the Business Development Manager here at Women in Cybersecurity. Before we get started with today's presentation, I'd like to give you a brief overview of the WESIS organization. WESIS is a 501c3 nonprofit organization with a mission to recruit, retain, and advance women in cybersecurity. We often go by our acronym WESIS, as in We Sis, because that's exactly what we are. We are a global cyber sisterhood. Our community is made up of over 11,000 members in 107 countries. We also have 69 professional affiliates and over 200 student chapters around the world. We offer a range of initiatives and skills development programs for all career levels. Also, all of the job openings from the WESIS strategic partners are available on the job board year-round. We are currently accepting applications for the Capture the Flag with Amazon and Fortinet, the Cyber Competency Builder with Just Hacking Training, and the Executive Leaders Network. We want to take a moment to thank all of our strategic partners who fund the organization year-round. Our Tier 1 partners are Amazon, Bloomberg, Cisco, Ford Motor Company, Google, Lockheed Martin, Microsoft, Palo Alto Networks, and SentinelOne. Feel free to ask questions throughout today's webinar. Please type them in the box below. And with that, I will turn to Shiny.
Hey everyone, so let me quickly share my screen for my presentation. I hope my screen is visible. Okay, so hi everyone, I am Shiny Basu. I've been part of Dell Technologies product and application security team for almost 6 years now. Over the past year, a significant part of my work has been focused on exploring how AI agents help us scale security across a large engineering organization. We have been experimenting with practical use cases, learning what works, what doesn't, and where AI can genuinely make a difference beyond the hype. Today, I would like to share some of those learnings and insights with you all, not just around the real world AI agent use cases in cybersecurity, but also some of the fundamental AI building blocks like prompts, skills, agents, tools, and MCP servers. Because understanding these concepts make it much easier to design AI solutions that solve real security problems. Also, I would like to let my audiences know that we have a poll going on, and if you could all pitch in your answers to the poll, that would be great. So the poll is about how you would describe your current use of AI at work, and please feel free to pitch in your answers for the poll. And yeah, let's go ahead. So every security team today is sitting on a mountain of data. Hundreds of security policies, hundreds of security controls, thousands of developers, millions of lines of code. The challenge isn't that we don't know what secure looks like. It's just that the sheer number of things to check or review has grown beyond what any human team can realistically tackle with. And this isn't static, it's compounding. With AI by our side, new applications are spinning up every other day. Dependencies change daily, new CVs dropping every week, faster than ever before. No matter how big our security team is, we are always falling behind the rate of change. So, what actually happens? Corners get cut. The same policy gets interpreted differently across teams. Some reviews are thorough, while others are rushed. It's not negligence, it's simple math. When volume explodes, consistency is the first casualty. And in security, inconsistency is exactly where risk creeps in. Right. Now, here's the interesting part. actually have all the context an intelligence system would need: policies, controls, SAST, DAST findings, the scan tool findings, the S bombs, CVs, threat intelligence. It's all sitting in our tools. AI isn't short on intelligence. The raw material for great security decisions already exists, but it stays siloed and manual, scattered across dashboards no single person can connect. You might say we already gate mergers on scans, like when scans report critical or high vulnerabilities, we do gate the mergers. True, the scanners flag, they don't decide. They are context blind, no sense of reachability, compensating controls, or false positives. So a human still triages every finding, and that costs us twice. Scanning every commit is expensive and noisy, and developers burn time hopping between the scan tool, a Gen AI tool, and their editor just to fix one issue. The bottleneck didn't disappear, it just got fragmented. And that is exactly where consistency breaks. Same evidence, different reviewers, different outcomes. But letting just AI decide isn't the answer either. AI hallucinates, right? So it can't be blindly trusted. So we are kind of caught in the middle. Humans don't scale. The raw AIs can't be trusted. That's the gap. And closing it the right way is what we will discuss today. So let's look at the shift that the security realm has seen in the past few years. Now, in the past, security knowledge lived in documents, policies, controls, best practices, all written down in PDFs or conference pages. Automation also existed. We built scripts, CI/CD pipelines, workflows, and rule based systems to automate repetitive tasks. But these two worlds were largely disconnected. Documents could tell you what should be done, while automation could execute predefined steps. Yet neither could actually understand context or make a security decision. Humans had to bridge that gap, reading the documents, interpreting the requirements, and deciding when and where automation should be applied. Now, in the present, today we have made tremendous progress. We have automation everywhere. And on top of that, we now have AI assistants as well. AI helps us write code, summarize findings, explain vulnerabilities, and even suggest remediation. That's a huge leap forward and is generally making us more productive. But here's the limitation. Today, AI mostly exists as an assistant, not as part of the workflow. We ask it a question, it gives us an answer, and then we go and do the work. It isn't connected to our enterprise systems, and it's not seamlessly baked into our ecosystem. It it doesn't gather evidence, it doesn't correlate information across multiple data sources, and it doesn't take actions. So when a security engineer needs to answer a seemingly simple question, should this merge request be approved, or is this control actually implemented correctly? They are still jumping between multiple systems, security scanners, policies, asset inventories, ticketing systems, manually piecing everything together before making a decision. AI helps us understand individual pieces of information, but humans still connect the dots. But now, the future that we are stepping into is coming in a leap on two fronts. First, from assisting to acting. AI decision agents don't just flag or suggest, they decide and take action, and they do it safely. Every decision is based on our real data, our scans, our policies, our asset inventory. No guesswork. And then only act within the rules or boundaries we set for it, the guardrails we define for it. Second, from a standalone tool to a connected ecosystem. Instead of isolated assistant that we visit on the site, like posting a question to chat GPT or the likes of that, we get a network of specialized agents that hand off responsibility to one another. And because every decision is backed by evidence, the agents resolve the clear cut cases themselves. The ones where the evidence is unambiguous and the reasoning is solid, and escalate only the genuinely ambiguous calls to us. So instead of wading through a mountain of obvious decisions, humans are left with just the handful that actually need judgment, stripping out an enormous amount of overload. And either way, resolve or escalate, the agent lays out all of its analysis in one place, every piece of evidence correlated and stitched together. So the auto resolved cases are fully auditable, and the ambiguous ones, they land on our desk with the whole picture already assembled. So that's the difference between an AI that hands us a to do list and an AI that actually closes the loop. No more digging around different sources to make one judgment. So, we have been hearing about AI prompts, skills, agents, tools, and MCP servers. These terms are often used interchangeably, and which makes them honestly quite confusing. So, here I would like to see the results from our poll because I had asked, and I see that most of the audiences have answered. They mostly use prompts with Gen AI models like ChatGPT, Claude, Copilot. Few of them have said that they are experimenting with AI agents, but very few audience members are building reusable skills and MCP servers. So I guess then this would help the audience to understand what an MCP server is and how how we can use skills, what they are, where to use what. I hope the upcoming slides are going to answer that for you guys. So now let me explain all these concepts using something we are all very familiar with: a restaurant. So imagine you walk into a restaurant and give your order. I would like a margherita pizza. Now that's a prompt. It's just an instruction or request. I'm telling someone what outcome I want, but not how to achieve it. In AI, a prompt is exactly the same. It's simply the request we give to the model, and the model uses its underlying knowledge that it has been trained on to answer your request. By itself, a prompt doesn't contain expertise or decision making. It just answers the request based on the data it has been trained on. Now, an example of a prompt is like, can you help me summarize this document, right? So that's a prompt. Now, moving on to, now imagine the chef doesn't have to reinvent the pizza recipe every single time. Instead, there's a standard recipe card. It tells the chef what ingredients to use, the quantities, the cooking temperature, how long to bake it, and even how it should be presented. Now, that's a skill. A skill packages expertise. Instead of writing a long prompt every single time, we capture the knowledge, the workflow, everything into one document and reuse it consistently. That is what a skill is. And to write a skill, there is a very standard structure that you need to follow. So let's look at how to write skills. So as you see, there are 7 items that you need to define in your skill document. And a skill document is usually a machine readable markdown format document. Now, the first thing that you need to define is the purpose, what the skill is designed to do. Second, when to use, in which scenarios that skill would be applicable. You need to define that. So, like for example, if you are writing a skill for JWT security review skills, say for example, so if JWT libraries are being used or authentication code is detected, then this skill would be applicable, right? So you need to define when it would be applicable. Then the next thing is security review checklist. So you need to give it a checklist of a workflow or a checklist of things that it needs to validate to accomplish the task. Now, in this context, for a JWT security review skill, the checklist could look like token signing, validating token signing, expiration, etc. And the fourth thing that you need to define is the OWASP company standards or the organization standards. So the skill should know what security guidance it should refer to in order to do the review, right? So you need to specify those standards which the skill should use to do the review. And you also need to define the secure and insecure examples. So this will help the AI to understand what a secure code looks like and what an insecure code looks like. So you need to state both kinds of examples in your skill. And also, lastly, the expected output format. So every skill should have a standard output format because the skill will be reused, right? And to make it predictable, the output format, so that it can be parsed, we can write a code to parse it. We need to define a standard format, output format for that skill. And optionally, you can also define if there are any other external references that the skill should use or could use while doing its review, the optional tools or APIs, right? So you could define that as well, such as, in this context for a JWT security review skill, dependency scanner or a CVE lookup, things like that. So now going back, now we understand what a skill is, right? Now moving on. Now let's make the problem a little more complex, right? Instead of ordering one pizza, the customer orders, I'm hosting a dinner for 10 people. Some are vegetarian, some are gluten free, and I would like appetizers and desserts as well. Now the head chef has to think, the head chef has to decide which recipes should be used, which dishes should be prepared, what order everything should happen in, which chefs should prepare which dishes. That's what an AI agent does. An agent isn't just following instructions, it is reasoning, planning, deciding, and taking action. And to give an example, the coding agents that many of you might be using, like Windsurf, Cursor, those are coding agents. And likewise, we can design agents for different purposes. So yeah, that's agent for you. Now, even the best of the chefs in world can't cook without equipments, right? They need an oven, a mixer, a refrigerator. So these are tools. Now, similarly for AI agent, uh, AI agent might also need to refer some external data or information and some external capabilities to gather more information in order to reason with the right source of information, right? So it may need to read a GitLab merge request or search Jira or query a scan tool or read a Confluence document, right? So these are all external tools. These are all the tools that AI could use to gather more information to accomplish a complex task. Now, here's when MCP comes into picture. Imagine a restaurant with an Italian chef, a pastry chef, and a grill chef. They all need ingredients and equipment, right? But instead of each chef walking directly into the pantry, refrigerator, supplier room, or storage area, they all go to one standardized service counter. The chef simply says, I need mozzarella. The service counter figures out where it is, which storage room has it, whether it comes from the pantry or today's supplier, and how to retrieve it, right? The chef doesn't need to know any of those details. That's exactly what an MCP server does. The AI doesn't need to know where the data comes from. whether it is going to come via a REST API or a GraphQL query or a database query or GitLab APIs, anything. It simply asks the MCP server for the capability it needs. And the MCP server handles all the backend complexities. So we define the tools that we need in this MCP server, and MCP server handles the complexity of interacting with the different tools and retrieving the right required information from the tools. So it's not replacing APIs, REST APIs. It's like a wrapper around these different protocols that we already have. But it's a protocol, a standardized protocol that AI applications understand and they use to discover and use tools. So now we have a fair amount of understanding of what a prompt is, a skill is, what are tools, MCP servers, and of course agents. But now the question is how to decide where to use what, right? So in order to decide what would be the right building AI building block in which scenario, you should ask. So the first question you could ask is, can I explain what I want in one prompt and the AI can finish the task without remembering anything or interacting with other systems? If yes, then use a prompt. For example, explain OAuth or write a Python script, translate to French, things like that. So for these kind of purposes, we can rely on the AI model's knowledge data that it has been trained on, and it's a fairly universal kind of question, right? So in those kind of scenarios, we can rely to use prompts. Now, the next question you could ask is, will I ask the AI to perform the same specialized task, ensuring a specific workflow and a standard output format many times? If yes, then you should create a skill. Now, for example, you could create a secure code review skill or a cryptographic algorithm audit skill or a resume review skill. You know, instead of rewriting the prompt with all the details and that structured format that we discussed, we could all package it all in one skill document, right? And it can be reused every time. Now, you could ask, does the AI need to plan the work, choose between multiple skills or tools, or perform several steps before producing an answer or executing an action? If yes, create an agent. Now, we will discuss use cases where an AI agent would make sense in our upcoming slides in detail. Also, you could ask, does the AI need information on performing actions on systems outside itself, or does it need data in order to make informed decisions? Does it need data from external sources? If yes, then you should integrate required tools using like the required tools REST API or the DB or CLI, whatever your tool has exposed. Um, and also now you could use RAGs as well. You might have heard of RAGs, retrieval augmented. So you could use RAGs, but it would, sometimes be an over engineering because if the data from a tool can be retrieved easily from a API call or a database call, then that is a better approach. Now, the last question you could ask is, will more than one AI application or agent need these same tools as well as skills? If yes, then that's when you should create an MCP server. So the MCP server would be a collection of tools, like it would have in backend the capability to talk to different tools and get the right data. It could have the tools to fetch certain skills that you define. So in those cases, you should use a MCP server, right? Now moving on, we have now talked about prompts, skills. tools, MCP servers. Now let's dive deeper into how AI agents work. And as we've already seen from our previous slides, that AI agent is much more than just a prompt. It's an application that has a goal, reasons through a problem, gathers information, decides what to do next, and ultimately takes the action. This slide shows what happens in the background every time an AI agent script runs. So the first step is how the AI agent is triggered and how the objective or the goal is loaded into the AI agent. Now, we could trigger the agent using, a webhook, which when a specific event occurs, would trigger our agent application, right? Or it could be triggered via a REST API, or if suppose we are creating the AI agent as a Python package, so the command that we expose as part of that Python package, that command could be used to trigger the agent, right? Or it could be a scheduled job that runs every night. That's where the agent could be triggered. So regardless of how it's triggered, the first thing the agent does is determine its objective and gather context needed to achieve the objective. Now, for example, if the agent is supposed to analyze a code or a Jira ticket, it would get full details on the code base, on the Jira ticket fields before proceeding with the next steps. And it would use the information that it has received when it's triggered to gain more context on like the code or the Jira ticket, right? Now, once the objective is understood, the agent begins breaking the problem into smaller, more manageable tasks. Each of these subtasks may require different expertise, which is where reusable skills become valuable, right? Or sometimes even a well curated prompt is good enough. At the heart of every AI agent is the reasoning engine powered by the large language model. And this is where the agent continuously evaluates the situation and decides what to do next. Unlike traditional software that follows a fixed sequence of instructions, an AI agent continuously reasons. It evaluates the information it has, decides what it needs next, gathers more information if required, and repeats the cycle. The output from one subtask is fed into another subtask uh, for further evaluation. And this interaction with the LLM is repeated until all the subtasks are completed. And how do we interact with the LLM models? It's using their APIs. So usually organizations have their in-house models hosted and they have their own APIs. So you could use that to interact with the LLM model. Or if there is no in-house model available, you could also use the open source AI models like Llama, to do the reasoning with. So now, as the AI agent reasons, it often realizes it doesn't yet have enough information. That's when it starts interacting with external systems, the tools, right? It may retrieve source code from GitLab, or vulnerabilities from scan tools, or it could get logs from the ELK, depending on the use case. And this is where tools and MCP servers come into play, right? The agent doesn't need to know how GitLab or Jira or the vulnerability tool works internally. It simply requests that capability it needs, and the underlying tools or the MCP servers retrieves the information and gives it to the agent. Now, once enough information has been collected, the agent correlates everything it has learned. It combines the output from all the subtasks and data sources into one complete understanding of the problem. Basically, it aggregates the findings and, based on a business logic, deduces what action should be taken. And finally, the agent takes the action. That is where AI becomes much more than a chatbot. Depending on the use case, it might add comments to a merge request, or create a Jira ticket, or notify a user, update a dashboard or a database. Depending on your use case, you would automate the action that should be taken as the end result of all the reasoning that our AI agent has done, right? So the real value of an AI agent isn't that it generates text, it's that it can make informed decisions and automate meaningful actions. Now, so far, we have looked at a single AI agent, right? But what happens when the problem becomes much more complex? Now, there are two options to address a complex task. First is a self orchestrating agent. In this approach, the agent orchestrates the work dynamically. As it reasons, it may decide, this requires Java expertise, or now I need Kubernetes expertise, or I need to analyze, the open source dependencies of the project. The agent can invoke specialized skills, or in some implementations, even special. It could spawn, sub agents based on what it discovers during its execution. So this is the self-orchestrating agent approach. Now you could consider reading about lang chains or lang graphs in order to learn how to, architect self-orchestrating agents. Now the option two is developer-designed multi-agent architecture. In this approach, the developers design the workflow explicitly. Instead of one agent doing everything, the developer who creates this multi-agent application breaks down the problem into multiple specialized agents. Now, you would ask which approach is better? The answer depends entirely on the problem. If the workflow is predictable, such as reviewing a merge request, a developer designed multi agent architecture is often simpler and more deterministic. But if the path is unknown, say for example, if you have to investigate a security incident, a self-orchestrating agent can adapt its investigation as new evidences emerge, right? So in that case, self-orchestrating agent would be a better choice. So now let's look at a real use case that brings together everything we have discussed so far. Imagine you are a developer who has just created a merge request in GitLab for the code changes that you have done. Before that code gets merged into production, someone needs to review it, right? Not just for functionality, but also for security. Today, security reviews are often manual. Security engineers don't always have the time to review every merge request. Developers may not know every secure coding practice. And with hundreds and thousands of merge requests being created every day, this simply doesn't scale. And this is where an AI agent can help. Now, everything starts when a merge request is created in GitLab by a developer. Um, and the agent could be triggered as part of the CI/CD pipeline, or the GitLab triggers a webhook that automatically invokes the security MR reviewer agent, right? So that's the input layer. Now, instead of asking one AI to perform every tasks, we have divided the work into several specialist agents. Each one focuses on a specific responsibility. Now, if you look at the architecture diagram, the first agent we have is the guardrail selection agent. Now, first responsibility is determining what should be reviewed, right? What the review should happen on the basis of. Every organization has different security expectations, and they have defined security controls, or we could use the predefined security controls by NIST. So, and these are like guardrails. These security controls are documented in machine readable formats, and AI could easily understand them. uh, the idea for all these security controls is to define what a secure software should look like. And now this guardrail selection agent analyzes the merge request, it gets the code diff and understands its security context. It defines the programming language that is used, or the frameworks that are used. infrastructure files, authentication mechanism, cloud services, containers, or any other relevant technologies. So it defines what the security context is. And it retrieves only the applicable guardrails that are relevant to the merge request. For example, if the merge request introduces JWT authentication, there is no need to review Kubernetes controls, right? So the agent goes and retrieves the JWT security guardrails or the JWT security review skills, right? Likewise, if a Docker file is modified, the Docker file security guardrail or a Docker file security review skill is shortlisted. Uh, this makes the review faster and also more focused. Now, the second agent is the signal extraction agent. This agent extracts important signals from the code changes based on the shortlisted guardrails or skills. Rather than sending the entire code repository to the AI, it helps extract suspicious security patterns from the code diff of the MR. In order to do so, it chunks the code diff into smaller, chunks, and also every chunk, all the chunks will have an overlap in order to, preserve the context. And for each chunk, this agent identifies any indicators of potential security violations. This agent returns structured JSON with evidence, the file path, line number, and the reason why it feels there could be a security violation in that line of code. Now, the next agent is the validation agent. The validation agent takes the shortlisted guardrails or skills and code snippets identified by signal extraction agent as the input. It reasons with the AI model to determine whether the signal is false positive or a true positive. And if it is a true positive, what is the severity of the violation, as well as the remediations for the security violation. The goal here is to reduce false positives and improve confidence in the review. So the validation agent takes care of doing that. Now, depending on your use case, you could add some more agents. Like here, we have given an example of Docker image agent or a dependency agent. Now, Docker image agent would, interact with the right tools like the Docker registry, and get in. So like if there is any changes in the Docker file in the merge request, and it will check whether the base image that is used in the Docker file, whether it's an approved base image, approved within the organization, and it would also check whether there are any known vulnerabilities present that are present in that base image, and things like that. It would evaluate, reason with the AI model, and also tells us if there are any secure alternatives present in our Docker registry. So the Docker image agent could help us with that. The dependency agent, on the other hand, could help us analyze the third-party libraries. It queries the software composition analysis tool to identify vulnerable packages, outdated dependencies, or components with known CVEs. Since modern applications rely on so many open source libraries, these provide valuable context that isn't visible from the code alone, right? And depending on your use case, you could add more agents to it. Now, the final result from all these sub-agents is delivered directly where developers already work, that is inside the GitLab merge request. We add inline review comments to the MR with explaining what the security violation is and also how to fix the violation. So the developers can, easily take in the security feedback and fix the code. So it makes this process much faster and much more actionable. Yeah, so now what excites me most about this use case is that AI AI is reviewing code. Static analysis tool have been doing code analysis for many years. The real value here is that AI can reason across multiple sources of information, understand organization security standards, correlate findings, and provide developers with meaningful contextual feedback exactly where they work, right? So now let's look at the second use case. Now, in my first use case, I was focusing on helping developers write more secure code before vulnerabilities could reach production. Right now, in this use case, we shift the perspective from the developers to the security organization. Today, most enterprises have a large number of security tools like SAST, DAST tool, infrastructure scanning tool, container scanning tools, and many more. Each of these tools produce valuable findings, but they all answer the same question: what vulnerabilities did I find? Very few answer the question security leaders actually care about. What do these vulnerabilities collectively tell me about my organization's security posture and risk? Right? Now, that's where AI can make a significant difference. Now, before we dive into this agent, let's discuss some common security controls that are defined in the organizations or defined by NIST. Right? Now, some examples are like secrets must never be hard coded in source code, or containers must use approved base images, or all applications must validate user input to prevent injection attacks, and sensitive data must always be encrypted. These are some examples of security controls. Now, rather than having one enormous AI agent that understands every security tool, we again divide the work into specialized agents. Each agent understands one specific security domain. Now, as you can see, we have a SAST agent that talks to the SAST scanning tool and gets the findings for a given system. And the findings could look like, say, it could report SQL injection vulnerability or cross-site scripting or weak cryptography, right? And traditionally, we would stop there. We would rely on the developers to fix these vulnerabilities, but AI takes the next step. It reasons over each finding and determines which organizational security control these findings violate. For example, a SQL injection finding may violate the organization's input validation control, right? Or a weak cryptography finding may violate the cryptography standards control. Now, similarly, the DAST agent performs the same reasoning with DAST scan tool findings. Now, the findings from DAST tool could look like, say, missing HTTP security headers, or authentication bypass, or session management weakness. These are some findings that the DAST tool could report. Now, again, this agent would reason with the AI model to understand which controls have been violated based on these findings. And on the same lines, the configuration agent. This agent analyzes infrastructure and cloud configuration findings. It identifies, public cloud storage being used, or container running as root, or overly permissive IAM permissions, or misconfigured Kubernetes resources, right? Things like that. And again, we would reason with the AI to determine which security controls are impacted due to these. Now, this is where AI begins providing insights, right, that are very difficult to obtain manually. Every specialist agent has mapped its finding back to the security controls. AI now combines that information across every application, every security tool, and every technology. Let me give you an example. Imagine your organization has five, say, for example, for the applications under your org are reporting 500 critical and high vulnerabilities. Now, that sounds alarming, right? But by itself, it doesn't tell you where the real problem is. Now, walk through slowly. The AI reasons over these findings and maps them to your security controls. And then we would know out of these 500 vulnerabilities, 220 relate to patch management, 160 relate to vulnerability management, 90 relate to unsupported software, 30 relate to secure configurations. Now we have completely changed the conversation. Instead of saying we have 500 vulnerabilities, we can now say our patch management control is consistently failing across our org. That's no longer a technical finding, that's a governance insight, right? Now, once the AI understand which controls are failing, it can assess the risk associated with each control. AI can assess the overall effectiveness of the control itself. Like, it would consider how many findings map to this control or how severe are the findings. Are multiple security tools reporting failures against the same control? How many critical applications are impacted? And is the trend improving or getting worse? So the final result isn't just another vulnerability dashboard. Instead, AI produces actionable insights such as which controls present the highest organizational risk, or which controls are consistently failing, which controls are improving, and where security teams should focus their remediation efforts first. So the risk scoring done by AI could help us deduce these actionable insights, right? This is particularly valuable for security leadership. Engineers still need vulnerability reports because they tell them what to fix, but like CISOs and security managers need something different, right? They need to understand whether their security program is actually becoming more effective over time or not. Ultimately, AI isn't replacing vulnerability scanners, it's just helping us reason over the enormous amount of vulnerability data they produce. Instead of simply counting vulnerabilities, we are understanding what these vulnerabilities collectively tell us about the health of our security program. That's the difference between collecting security data and making informed security decisions, and that's where exactly the AI agents enable us to do at scale. Now, throughout this session, we have seen AI can review code, it could correlate findings from multiple security tools, map vulnerabilities back to security controls, and generate actionable recommendations, right? Now, at this point, a question naturally comes to mind. If AI can do all of this, what happens to security engineers, right? But I believe we are asking the wrong question. The question should be, will AI replace security engineers? Shouldn't be this. The better question to ask is, how can AI help security engineers become exponentially more effective? This infinity symbol here represents continuous collaboration between humans and AI. The goal isn't automation just for the sake of automation. The goal is enabling security expertise to scale far beyond what is possible today, right? Now, think about a typical enterprise today. One security engineer may be supporting hundreds or sometimes even thousands of applications. They are expected to review secure architectures, answer security questions, investigate vulnerabilities, and respond to security incidents, as well as validate security controls, right? But the reality is there simply aren't enough security engineers to manually engage with every application and every code change. But AI changes that. The first benefit is that AI becomes a force multiplier. Think about two examples we looked at today. In the security MR reviewer, AI wasn't inventing new security knowledge, right? It was just applying the organization's existing guardrails, secure coding standards, and best practices automatically for every merge request. Now, similarly, in the control risk assessment use case, AI wasn't replacing the security team's expertise. It was correlating findings from multiple security tools, mapping them back to organizational security controls, and helping identify where the organization's greatest risk actually exists. In both cases, the knowledge still comes from the security engineers. AI simply applied that knowledge at scale, which humans alone never could, right? Now, the second advantage is consistency. Humans naturally have different levels of experience. One reviewer may identify an issue that another reviewer might miss. One analyst may map a vulnerability to one security control while other might interpret it differently. AI applies the same organizational guardrails, the same security standards, the same review process, and the same control mappings every single time. This doesn't replace human expertise. It ensures that expertise is applied consistently across the entire organization. The third benefit is definitely speed. Developers often wait hours or even days for feedback on their merge request. Likewise, correlating findings across multiple tools to understand organizational risk can take days or even weeks. AI can perform these analysis in minutes. That means developer receive faster feedback while they're still working on the code, and security teams gain faster visibility into emerging organizational risks. Now, finally, AI dramatically improves coverage. No security team can manually review every merge request, right? Every dependency, every container image, every cloud configuration, and every vulnerability across thousands of applications. Similarly, no analyst can continuously correlate findings from SaaS, DAST, infrastructure scanning tools, other vulnerability scanning tools across an entire enterprise in real time, right? Now, AI allows us to extend security expertise across far more applications and systems that would ever be possible manually. It's not about replacing security engineers, it's about enabling their knowledge, decisions, best practices to each and every corner of the organization consistently, rapidly, and at an enterprise scale. Now, on a closing note, to me, the future of cybersecurity isn't human versus AI, it's human plus AI. AI has some incredible strengths. It can review enormous amount of information. It can identify patterns that humans may overlook. It can explain why something is a problem. And it can generate recommendations almost instantly. These are exactly the kind of repetitive, data intensive tasks that AI is exceptionally good at. But there are equally important things that still require human expertise. Now, judgment. AI can provide recommendations, but humans decide whether those recommendations make sense in the context of the business, right? Accepting risk. One of the most important responsibilities in cybersecurity is risk acceptance. Sometimes the technically perfect solution isn't the right business decision. Say perhaps a production system cannot be upgraded today because it's supporting a critical customer, right? Perhaps compensating controls are already in place. Those decisions require understanding business priorities, operational constraints, and organizational risk appetite. That's something AI can inform but not own, right? And architecting. Designing secure systems require creativity, trade-offs, and experience. AI can suggest secure design patterns, but deciding how to architect a system that balances security, performance, usability, and cost remains a human responsibility, right? And finally, governance. Humans define the policies, humans define the guardrails, humans defines what acceptable risk looks like. AI simply helps us apply these decisions consistently at scale. And in conclusion, I would like to say policies define what secure looks like. AI helps operationalize those policies into decisions. And humans ensure those decisions are the right ones and instruct AI on how to arrive at the most accurate decisions. Thank you. I hope this was helpful and it will give you a head start on, designing use cases, designing AI agents for your use cases, which could help you in your day-to-day work. So now, if there are any questions that are there, we could look at that. So I see there is one question. Okay, with AI agents making security decisions at scale, how do we make sure human oversight is still there to avoid costly mistakes? Second question, what is the biggest challenge? Okay, let me answer the first one. Okay, so now, like I had mentioned, right, when AI is taking any decision, it always gives us, we will always document the reasoning, the evidences, the data, everything that the AI has stitched together to arrive at that decision, right? We will audit all of that so that if in future there's something that goes wrong, we could go back and see why AI arrived at that decision and what evidences uh, made the AI take that decision, right? So and even like if the AI is unsure, we could have something called a confidence scoring in place. AI could tell us how confident it is about a certain decision, and we could have a threshold defined, that if the confidence score is higher than 90 or above, then it should go ahead and take the action. But if it's lower than that, then it should flag and probably notify the right security engineers. And depending on the risk appetite of the application, you could balance your threshold. So I hope that answers that question. uh, Now the second question is, what is the biggest challenge when moving from a written security policy to letting an AI agent actually enforce it? uh, so see, these policies are usually written in markdown formats which are machine readable. Now, and these policies are very specific. Each security guardrail is very specific to one area of security. Like I had mentioned, like we could have that all the applications must have input validations, right, to prevent injection attacks, and they are very specific around one area. So AI can understand that context, and it can understand the code context and deduce. It could relate the two and apply it. You get it? So it understands context very well. It's just that we have to give it the right information to take the decision, right? And in this case, machine readable policies, like I had explained in the MR reviewer use case, that we could have a guardrail selection agent which would pick what guardrails are actually applicable for that code change, right? And instead of sending all the guardrails, it would pick and choose which are the relevant guardrails for that uh, code change, right? So that's how the agent, the AI could effectively ensure that the policy is being applied correctly. Now I see there's a third question. For someone new to this, what skills should women in cybersecurity be learning now to work with AI agents, not get replaced by them? I'm sure AI agents are not going to replace humans, but yes, certain skills could definitely help, make our lives more easier. See, first of all, I think we should learn Python scripting. That is the first thing. We should understand how to write Python scripts, because that's the most relevant language to use in these kind of scenarios. There could be other possibilities as well, but yeah. And most importantly, you just need to understand how APIs work, because you have to invoke the LLM model using the API, right? It's API, so you should know how to work with APIs, and also how to write well curated prompts that have all the necessary information and guidelines on what that AI model should follow to arrive at, to get you the answer or to arrive at a decision, right? So you should know how to structure your prompts properly, curate them, they should be detailed enough. And I would say, uh, and in general, I think after today's session, you have a fair amount of idea on what a skill is, what a prompt is. So just go back and maybe try implementing a skill. And when you start working with it, and anyway you have these coding agents at our hands with us, right? So these AI coding agents can help you create these agentic applications very easily, as long as you understand the AI building blocks, right? So yeah, so read about MCP servers, skills, RAG, and where to use what, because most of the times, things we hear and use could be an over engineering, So just take the right decision based on each based on the concept of each of these AI building blocks. Can you share a real example where an AI agent successfully operationalized a security policy that was hard for human to do? I guess I have shared quite a few use cases in my presentation today. Like we could use it to review our merge requests or get insights on what security controls are being violated based on the findings from the scanning tools, right? And we could also use it in as a SOC analyst. So whenever a security alert comes in, we could have multiple agents which are interacting with different data sources like the logs or the vulnerability tools and all, and then arrive at a decision on whether a security alert is false positive or true positive. And if it's a true positive, we could automate the patching process, pushing the patch to the affected asset, and if it's a false positive, suppress it, and maybe have all the reasoning as in why AI is saying that it's a false positive. So yeah, there are a couple of uh, there are a lot of use cases where AI agents could be helpful, and I guess that's it. I I don't know if I'm missing out anything. Uh, yeah, that's it. And I guess uh, this was helpful. And do reach out to me on LinkedIn if you have any further questions. Uh, I would love to answer them or have any discussions with you guys. So thank you. Thank you so much.